Okay, Assalamualaikum warahmatullahi taala wabarakatuh. Okay, good morning everybody. Now 1 o'clock in the morning. Okay, I want to discuss here Sidesway frame analysis. Okay, under the textbook, this is chapter number 12, moment distribution method. Actually, some of the theory, some of the concept regarding Sidesway frame analysis have been discussed in chapter 11, which is called as slope deflection method. It is including how to identify frame without sidesway and with sidesway. Okay, I will start with that. Okay, before we continue with analysis, okay, we need to be able to identify the frame, no sidesway frame or sidesway frame. Okay, actually there are two conditions that we need to understand. Okay, these two conditions, as I said just now, have been discussed in chapter 11 under sidesway frame. Okay, number one, okay, the frame is non-sway frame or no sidesway if the frame is symmetry due to loading and geometry. So this is the condition for non-sway frame. Non-sway frame or no sidesway. Okay, no sidesway. Okay, condition number one, when the frame is symmetry due to loading and geometry, like this. For example, okay, this is the frame. Okay, same support, same EI, length is equal. This is L, this is also L. Okay, the frame is subjected to point load P at the center of the beam L/2. Okay, this is symmetry. This frame is symmetry due to loading and geometry. So this is non-sway frame. Non-sway frame. Okay. Okay, let's consider what happened to this one. Let's say if I have frame like this, but this time, okay, the load, the P is subjected not at the center. Okay, let's say like this. It is L/3 and 2L/3, means P is located not at the center. So this frame is unsymmetry due to loading. So this is unsymmetry due to loading. Okay, even though the geometry is symmetry, but it is unsymmetry due to loading. So this is sidesway frame. Okay, another example. Let's say if loading is symmetry, but geometry is not symmetry. Okay, loading is symmetry. It is L/2, but the column one is L1, another one is 2L. Okay, so this one is unsymmetry due to geometry. So this is also Sidesway frame. So unsymmetry due to geometry is not only depend on the column length. Okay, sometimes when EI is not constant, let's say EI for column AB is 2 or is EI, and EI for column CD is 2 EI. So due to the moment of inertia due to I is because I is come from the cross section, so different I means the geometry is not symmetry as well. Okay, so I hope you understand the definition of a non-sway frame based on condition number 1, symmetry due to loading and geometry. Okay, we move to condition number 2. Okay, condition number 2. Okay, number 2, it is unsymmetrical frame, but it is properly restrained. The keyword is properly restrained. Okay, it is unsymmetry, but it is properly restrained. Okay, for example, like this. This is the frame. Okay, this is unsymmetrical, subjected to loading. Okay, properly restrained means if we have a support that brings the horizontal reaction due to the support R, okay, means R is actually the restraining force. Okay, due to the support, the frame is held from sidesway, so R is called as restraining force. This is called as restraining force, which comes together with support. Okay, so our focus now is a horizontal reaction which comes with support. Okay, so this is called as properly restrained. Okay, let's look at another example. If this is the frame, but okay, this time I changed fixed just now. The previous one is fixed. I now change to pin. Okay, due to pin support, is there a horizontal reaction due to pin? Yes, there is a restraining force. So this frame is also called as properly restrained. This is unsymmetrical frame, but it is properly restrained. So this is non-sway frame. So this is non-sway frame. This is also non-sway frame. Okay, let's consider the other one. Okay, this is unsymmetrical. Okay, what happen if I change pin to roller? Is there any restraining force? Is there any horizontal reaction due to roller like this? No, there is no restraining force. So this one is sidesway frame. But what happen if I change the position of roller like this? So due to the position roller like this, there is a restraining force which comes with support, restraining force. So due to the support, the frame is held from sidesway. So this is properly restrained. This is unsymmetrical frame, but it is properly restrained. So this one is non-sway frame. Okay. So if we have this one, just like this, okay, P like this. So due to this, this is unsymmetrical, right? This is unsymmetrical due to loading. So the frame will sidesway. So if we want to make this properly restrained, we must put, because this frame is tend to sway like this, okay. So this is delta. So if we want to change this condition to non-sidesway frame, we have to put this like this. From sidesway means we must put support here. Pin or roller doesn't matter, in order to bring R like this. So this is also called as properly restrained. So this one is sidesway, but this is non-sway. Okay, so please remember there are two condition for non-sway frame. Number one is symmetry. It must be symmetry due to loading and geometry. Number two, if it is unsymmetrical frame but it is properly restrained, okay, it is also considered as non-sway frame. Okay, properly restrained means the frame the original frame without R or without support, the frame is tend to sidesway. But due to the support, there is a horizontal reaction which is called as restraining force. Due to this restraining force R, the frame is held from sidesway, so it is called as properly restrained. Okay, now I want to discuss this one under a subtopic 12.5 moment distribution for frame with sidesway frame. Okay, I want to explain this because this is the textbook that will actually be used in many universities around the world. Use this as the main textbook. So this Hibler textbook is the best reference, not the lecture notes. Okay, so please refer to the main textbook. Okay, now I choose to use Hibler as the main reference. So we try to understand what is actually the writer explain about moment distribution for frame for sidesway. Okay, focus on this one first. Frame with Sidesway. Okay, since by looking at this frame, this is diagram A. By looking at this frame, the frame is tend to sway to right direction. Okay, due to force which is unsymmetrical, subjected unsymmetry to the frame. Okay, this frame is unsymmetry due to loading. So there is an external force in the frame, as well as that due to unsymmetrical condition, the frame is tend to sidesway. So sidesway means has delta in the frame. So there are combination of two now. One is external load, one is delta. Because remember, FEM, okay, end moment can exist, end moment occur due to two conditions. One is from external load, and another one is come from delta. Moment can also occur due to delta. Delta in frame is commonly we discuss on the sidesway. Okay, sidesway. It is not like beam, where beam delta for beam is come from support settlement, and support settlement is also given in the question. Support settlement is given in the question. So let's say like this. So the delta is given, but what is actually happen here, the delta in frame is not given in the question. Okay, so in this frame, there are P and delta together, but since P is known value and delta is unknown, so we cannot analyze sidesway frame just like we analyze beam. Okay, let's read together. Okay, the frame in the figure just now is non-symmetrical, subjected to non-symmetrical loading. It is non-symmetrical frame due to non-symmetrical loading and have tendency to sidesway because unsymmetrical, and this is not properly restrained, right? So this is sidesway frame. Okay, here the applied loading P will create unequal moment. Okay, P create unequal moment at joint B and C, such that the frame will deflect an amount of delta to the right. Okay, frame with sidesway, whether it moves to the right or it moves to the left, it is assumption. Normally, if we cannot sure where is the direction of the frame, we can assume the frame is tend to sway to right direction. However, sometime when there is a loading, a horizontal force come from right, like this. Okay, if sometime frame is like this, so this one is clearly show that the frame is tend to sway to left direction. Okay, if not it is okay, this shows that the frame is tend to sway to right direction. Or if you don't sure like this, we may assume that the frame is tend to sway to right direction. Okay, to determine this deflection, an internal moment, which is end moment, at the joint using moment distribution, we will use the principle of superposition. So I want to highlight this principle of superposition. Remember that we actually have used the principle of superposition in flexibility method whenever we derive the compatibility equation. And again, we use the same principle in order to determine the end moment in this frame. Okay, we apply the principle of superposition. Okay, how to do that? Okay, let's look at diagram B. It is called as artificial joint applied. Okay, artificial joint applied means that, okay, the frame, just now we assume that the frame is tend to sway to right direction. So we want to, when the frame is tend to sway to right direction, means in original frame there are the effect of external load and delta. But since one is unknown, one is known, one is unknown, we have to analyze FEM separately. So we have to divide the frame into two. Okay, the first one we will analyze the FEM due to external load only. External load only means we have to remove delta from the system. So whenever we want to do that, means that we have to put an artificial joint at C. Okay. Okay, diagram B is first consider help from Sidesway. This is actually properly restrained by applying an artificial joint at support C, because we know that at original frame the frame is tend to sway to right direction, so we have to put an artificial joint at C. Artificial joint means we can put roller, we can put pin in order to bring R together with the support, because R is the restraining force. Okay, this is the restraining force. So R comes with support. So due to this artificial support, the frame is now called as no sidesway frame or non-sway frame. Means that we have removed delta from this. So by having this, we can calculate the FEM due to external load only. Okay, we remove delta. Okay, we can analyze FEM. We can analyze due to external load only. Okay. Moment distribution is applied, and then by static, the restraining force R is determined. The equal but opposite restraining force is then applied to the frame in figure C. Okay, and the moment in the frame are calculated. So to fulfill the principle of superposition, these R have to be neutralized. So in order to do that, we have to add with another diagram. Okay, if this is negative R, so we have another frame subjected to positive R, so that, okay, so for diagram C, it is a frame subjected to positive R in the right direction, so that the frame is tend to sway to right. Okay, right direction. So here is the delta that we removed just now. It means that this one we will analyze FEM due to delta. Okay, B will analyze FEM due to external load only, and diagram C, it is FEM due to delta. Okay, so let's check together. Using principle of superposition, it is P plus 0 equal to P. Okay, then it is 0 plus delta equal to delta, and it is negative R plus R equal to 0. So the principle of superposition is now fulfilled. So next is one method for doing this last step require first assuming a numerical value for one of the internal moment M prime. Using moment distribution and static deflection delta prime and R prime corresponding to the assumed M prime can then be determined. Since linear elastic deformation occur, R prime develop moment in the frame that are proportional to those developed by R. Okay, for example, if M prime and R prime are known, the moment at B developed by R will be MdA, M equal to M prime times R divided by R prime. Okay, it is like this. Okay, we will analyze this using two table. In table 1, we will analyze diagram B. So this is table 1. In table 1, we will calculate FEM due to external load only in table 1. And after that, we will get N moment. And we will determine R value using static equilibrium. Okay. However, by looking at diagram C, can we calculate FEM directly? No, because delta is unknown, and we don't have to calculate the delta actually. So what we can do is introducing another diagram which is proportional with C. Okay. Okay, so now let's consider diagram C. It is like this. R. Okay, due to R delta. Okay, this is diagram C, and we introduce diagram D, which is proportional with diagram C. Okay, this frame is subjected to R prime. So due to R prime, there will be delta prime at B and C, delta prime. Okay, C and D. Both is Sidesway frame, but we cannot assume here. We cannot assume here. Cannot assume, but we have to assume FEM here for diagram D. Okay, so when we assume FEM, we will calculate n moment, and n moment for diagram D is due to R prime. There is a delta, and due to delta produce moment, so the n moment is m prime. Here is m prime. So m prime we get from table 2. So this is actually table 2. Okay, so actually okay, by looking at diagram C, due to R there is delta at B and C is the same amount, delta, and delta produce moment, n moment. So n moment in diagram C is m. Okay, so by comparing these two table, these two diagram, by comparing these two diagram, okay, in D table 2 we will determine m prime, and after that we using static equilibrium we determine R prime. So these two value is now unknown value. Okay, in diagram C, known value is R because we determine R after we determine n moment from table 1. So the unknown here is this one. So let's say we have two triangular because we want to do interpolation, proportional, C proportional with D. Okay, if this is M, this is R, and this is M prime and R prime. Okay, these four value, R is known value, R prime is known value, M prime is known value. Can we determine this M using interpolation? Can, right? Okay, it is M divided by R equal to M prime divided by R prime. So we want to have this, so it is M equal to R divided by R prime times with M prime. Okay, and R divided by R prime is called as correction factor. So since A is equal to B plus C, A is equal to B plus C, this is A is equal to B plus C, and in table 1 n moment is m naught, let's say m naught. Okay, in C m, okay, n moment. So n moment, the final n moment for A, let's say m final. So A is equal to B plus C, so MF is equal to m naught plus m. So it is A equal to B plus C, right? Okay, it is MF equal to m naught n moment from first table plus m, and m is unknown, and m we have derived from this. Okay, and m is equal to R divided by R prime times with M prime. So this is the equation which is derived from principle of superposition. Okay, so M naught is from table 1. It is n moment for non-sway frame, and M prime we get from table 2, distribution table. It is Sidesway frame, and R divided by R prime is called as correction factor. Okay, I can summarize the process to analyze the Sidesway frame using 4 steps. Step number 1, we need to calculate K, the stiffness factor and distribution factor. Okay, step number 2 is called as non-sway frame analysis. Okay, so under this it is FEM due to external load. Okay, after that, after we determine FEM, we determine end moment. M naught, this is from table 1. Okay, using moment distribution method. And step C, to C, we have to determine restraining force, which is R. Okay, using static equilibrium. Okay, so this will be based on this one. Let's say like this. So this is a restraining force here, comes with support. Okay, and step number 3 is for Sidesway frame analysis. A. Okay, for Sidesway frame analysis, we have to assume FEM due to Sidesway, due to delta. B, we will calculate end moment M prime from table 2, and after that we will calculate restraining force R prime using static equilibrium. And after that, okay, for this one it is Sidesway frame due to R prime. Okay, here is delta prime. Okay, this is M naught and this is M prime. Okay, and step number 4 is just the formula. It is final end moment M final, which is equal to M naught plus R divided by R prime times with M prime. Okay, so this is actually the summary. Okay, for the Sidesway frame analysis. For the Sidesway frame analysis, I divide into 4 main steps. Number 1, we need to determine the stiffness factor in order to calculate the distribution factor, and we will use the same distribution factor for step 2 and step 3 for table 1 and table 2. Okay, there are 2 tables. Table 1 is for non-sway frame, table 2 is for Sidesway frame. So the difference in this table is only due to FEM, because FEM For table 1 is due to external loading only, and FEM in table 2 is due to delta only. However, for step number 3, we have to assume FEM. What we will do is we will assume FEM for one member, and we will calculate the FEM for the other member. Okay, it is actually based on ratio. Okay, and after that we determine FEM based on the assumption value of first FEM. We will calculate the end moment from table 2, and the end moment is M prime, and after that we will calculate the restraining force R prime. Actually, step number 2 and step number 2C and step number 3C is the same process. Okay, and lastly, we can determine the final end moment, which is M naught plus R divided by R prime times with M prime times with M prime. Okay, this actually fulfill the principle of superposition. Okay, okay, I will show to you the example in the next video. Thank you very much. Assalamualaikum.